All right, CUA 6A retake. I'm going to apologize in advance because you're going to hear all the clickings of my stylus. I'll do number 1, you do number 2. Which of the following numbers, sets of numbers, could represent the lengths of the sides of a triangle? So what you're going to do is add together the two smaller sides and see if it's greater than the largest side. So is 2 plus 2 greater than 5? No. Is 3 plus 3 greater than 5? Yes. Is 4 plus 4 greater than 8? No. Is 5 plus 5 greater than 15? No. So B is our correct answer. Go ahead and try number 2. Number 3, classify ABC according to its sides. A is at -1, +2. B is at 4, 2. C is at 3, -1. We're going to go ahead and connect that into a triangle. All right, Shell, as I'm looking at this, it's obvious that this side, BC, is shorter, but AB and AC, they could be congruent. I can't 100% tell. What I can see is that 1, 2, 3, 4, 5. AB is 5 units long. Let's see how long AC is. We can't count it because it's diagonal. We're going to have to use the distance formula. All right, so for AC, we're going to use A as x1, y1, and C, as x2, y2. So AC is going to equal, or the distance from A to C, is going to equal the square root of x2 is 3, x1 is -1, y2 is -1, y1 is 2, and then we're going to work that out. Okay. All right, and we get 5. So that means this side is also 5, and we know BC is shorter. We can just look and tell. So this is isosceles. If you're not 100% sure about BC, you can just do the distance formula again. All right, number 4, given triangle ABC, classify. Go ahead and try that on your own. Number 5, compare the sides. So we're just trying to see which one is greater, which one is less. Okay, BC is here. DA is here. Neither of them have a number on it, so we can't do it that way. So we're going to just look at the angle that's opposite, like that. The angle that's opposite DA, like that. So the angle opposite BC is 70 degrees. The angle opposite DA is 67 degrees. Which one is greater? 70. And that's how you can do that. Go ahead and try number 6. Number 7, triangle ABC is below. What is the value of x? So this is triangle sum theorem, so we're going to have to add up all 3 of these. 3x plus 8, 9x plus 7, 3x, and make them equal to 180, because all 3 angles in a triangle will add up to 180. And we're going to go ahead and solve. You can use solve if your teacher allows you to, but if not, you're going to have to show your work by hand. Don't forget, when you do solve, you're going to write the equation. Hold on. Okay, so you're going to write the equation. I'm just going to copy paste that and shrink it because that is not going to fit there. Okay, sorry. Put the equation and then comma x when you do solve. Okay, just like that. All right, so we're going to combine these like terms. And that'll be what, 15x. We're going to combine these like terms. That'll just be 15. Then we're going to subtract 15 from both sides. That'll give us 165. We're going to divide both sides, Divide both sides by 15, and we get 11. All right, go ahead and try number 8. Number 9, given the vertices ABC, we're going to classify using the distance formula. So we're going to classify by sides. All right, again, we got the distance formula. And we're going to go ahead and do AB first. So we got x1, y1, x2, y2. We'll just use those for now. All right, x2 is -1, x1 is just 1. Y2 is -1, y1 is 4. And we're going to type that into the calculator. Okay, so I get 5.39 when I round it. Okay, now let's do BC. So the y1 and all that jazz is going to scooch over like that. Okay, so that'll give us 5 minus -1, -1 minus -1. All right, so I get 6 for that one. And then we have AC for the last side. So I'll just put this back over here with A. Okay, and I get 6.4. All right, so this is scaling because all 3 sides are different. All right, go ahead and try number 10. Number 11, the lengths of 3 sides of a triangle are 5, 9, and x. What are all possible values of x? What you can do here is subtract these 2 values, add these 2 values, and that'll give you a range of possible side lengths. So x can be any number between 4 and 14. Go ahead and try number 12. Number 13, solve for x using exterior angle theorem. So we're going to add these 2 and we're going to make them equal that one. So it's going to be 2x plus 5, these 2 remote interior angles. And then add it to the exterior, make it equal to the exterior angle. And then solve for x. Again, you can use nsolve if you want to. So I'm going to go ahead and combine these like terms. And then I'm going to subtract 2x from both sides. I'm going to subtract 8 from both sides. And then divide both sides by 2. All right, go ahead and try number 14. Number 15, triangle ABC is graphed, classify it. Okay, so, hopefully you can see here that this is an isosceles triangle. I know we can't count these 2 sides, the AC and the AB, But you can kind of see 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we got a 6 and a 12 here. That's important because we can use that to figure out like if the other side is the same. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so these two sides are the same. This one down here is 12. So this is isosceles. And I didn't have to use the distance formula, but you can. You can definitely use the distance formula. All right, go ahead and try number 16. You can use graph paper, or you can use distance formula. Number 17, the length of the side of an equilateral triangle is represented with 2x minus 1. If the perimeter of the triangle is 21, what's the value of x? All right, so if this is equilateral, all three sides are the same, which means I can just do this. All right, so we can have 2x minus 1 plus 2x minus 1 plus 2x minus 1. Or just multiply by 3. And then set that equal to 21. All right, so that'll be 6x minus 3 equals 21. If we add 3 to both sides, that'll be 6x equals 24. And if we divide both sides by 6, we get x equals 4. Go ahead and try number 18. Number 19, which triangle can be constructed using the following steps? All right, I'm not going to read that. I probably should read it, sorry. Okay, put the tip of the compass on point A. So I'm going to put it right here on point A. And then open the compass so that the pencil tip is on point B. And then we're going to draw an arc like that. Without changing the opening, put the metal tip on point B. And then we're going to draw this arc. What did we just create? Well, if this measurement was used to create this intersection here, then all three of these sides should be equal. So this should be equilateral. Okay, for number 20, if we had kind of a similar setup, so this is A, this is B, and then we put our compass here, but then we measured greater than or past point B, then we would have an arc like that. And then same thing with point B, we would have an arc like, oop, that was ugly. I'm doing this without using I'm struggling. I'm clearly very much struggling. Okay, we're gonna rock with that. All right, so if we were to do that, I'm just gonna, let me, if I can duplicate it, there we go. There we go, my goodness, that was so dramatic. Okay, so now we have this point up here. So this time, the radius is longer than AB, and that radius was used to create this intersection. So basically, these two sides created should be longer than B. So if these two sides are longer, then tell what kind of triangle that would be.